In the example, I'm going to show you how to find the relative extrema by using the first derivative test. Given the function, first thing is we have to find the critical value. To find the critical value, we need to find f prime, which is 6x squared minus 6x minus 12. Then z equal to 0, solve for x. I see that we can factor out the 6. And then we'll factor out some more. Plus 1, and then here I have minus 1. So I have x plus 1 equal to 0, or x minus 2 equal to 0. To solve for x, we have minus 1 and positive 2. These two values here will be our critical value. Now, this value here will help us to determine if we have maximum or minimum. And to do that, we have to using the f prime or the first derivative test here to see whether our graph will increase or decrease. And to do that, we have to test the interval. If we had somewhere around here is minus 1, somewhere around here 2. These are our critical value. So these two values here divide our real number line into 3 intervals. The first one is minus infinity to minus 1. Then the second one is minus 1 to 2. And the third one is 2 to infinity. Okay. We'll pick a point and a test using the first derivative. I'm going to pick minus 2 because minus 2 belongs somewhere inside here. So I put minus 2 in f prime, which is 6 times minus 2 squared minus 6 times minus 2 minus 12. So I have 6 times 4 plus 12 minus 12. Now you see, wherever the number comes out, we don't care. I see that our f prime at minus 2 is greater than 0, or in other words, it's positive. So that means that our interval from minus infinity to minus 1 is increased. When f prime is positive, our graph is increased. Our graph of f is increased. We do the same thing for this interval by pick 0. So put f prime of 0. Because 0 is lies somewhere on here. So we have 6 times 0 squared minus 6 times 0 minus 12, which is less than 0. F prime is less than 0, or this minus number. So this means from minus the interval of minus 1 and 2, our graph will be decreased, because when f prime is minus, that means our function, the graph of our function is decreased. So I'm going to draw like this and remind myself. Then the last interval, I'm going to pick 3. Okay, so we have 6 times 3 squared minus 6 times 3 and minus 12. So we have 6 times 9 minus 18. I don't really care to know what exact value of this, but I do know that equal to something is positive number. If f prime is the positive number, that means the graph of our f function is increased, like that. You see the sign is changing from this interval to this interval here, from a positive interval to a negative interval. Therefore, I have maximum. You can see right here. If you go from increase and then decrease right here, I have maximum at -1. I'm changing the sign here, changing from minus to positive. This means we have minimum. You can see clearly here. I draw the line here. This means I have minimum. Right here, I go decrease, go to increase. I have minimum at 2. So therefore, by the first derivative test, f have relatively maximum at -1. And we need to know what is the maximum. So to do that, we have to put -1 inside our f function. So we have 2 times -1 to the cube minus 3 times -1 minus 12 minus 1 and plus 12. We have -2 minus 3 positive 12 positive 12. So I have 19. Okay, this is our relative maximum. 19 is our relative maximum. So our relative maximum is 19 at where at x equal to -1. Okay, we also have minimum. We have minimum at 2. So we want to know what is our relative minimum by put 2 inside our f function. So I have 2 times 2 to the cube minus 3 times 2 squared minus 12 times 2 plus 12. When we simplify, I have 2 times 8 minus 3 times 4 minus 24 plus 12. And put other number in the calculator, and we have -8. So this is our relative minimum. So that is our answer.